Hi guys, welcome back. So I'm going to do 11.4 in two different sections. On first one, I'm going to talk about theoretical probability. And theoretical probability is when your sample space, or your S, has the same equal likely outcomes. And so we call theoretical probability P of E, and they're capitalized, okay? And it's the number of outcomes divided by the total possible outcomes. Running out of space there, sorry. Okay, so let's talk about this in a couple different things. So if I have a coin, okay, coin has two different possibilities. You can either get a heads or you can get tails, right? So if my event, I only want to look at the number of times I get tails, okay? My sample space consists of two possibilities, either heads or tails, one or the other. Okay, so if I'm looking for tails, my probability, theoretically, is I get tails up, so I get a tails, over my total tosses. So the number of times I toss the coin and however many times I get tails up. Now theoretically, I have an equal chance of getting both, okay? So my number of tails that I get over my total number in my sample should be equal to 1/2. I have equal opportunity to go ahead and get either a heads or a tails. All right, let's look at this in terms of dice. So if I have a 6-sided dice, and that's the only one we're going to be dealing with in this course, okay, I have 6 possibilities. I can either get a 1, a 2, a 3, a 4, a 5, or a 6. Okay. So my chances of getting 1 are 1 out of 6, given that I have equal chance of getting anything. My chances of getting a 2 are also 1 out of 6. My chances of getting a 3, you guessed it, 1 over 6. A 4, 1 over 6. A 5, 1 over 6. And a 6, 1 over 6. Okay, and the whole point is because these are theoretical, so I should have an equal chance of getting everything. If I were to go ahead and add these together, okay, I would get 6 over 6, which is equal to 1. So all of your probabilities should go ahead up and add to 1. Think about my coin. If the possibility of getting tails is 1/2, and my possibility of getting heads is also 1/2, when I add those together, I get 1. All right. The third thing you're going to be dealing with is decks of cards, okay? And you can see it all pictured. You may want to label on page 124, okay, so that you can go ahead and label them. All right, so I have 3 different picture cards. Okay, we don't include Joker in a regular deck of cards. So my deck is 52 cards total. I have 4 suits. Okay. And each suit has 13 cards, including the face cards, or my picture cards, as they're called. Okay. I have jacks, I have kings, I have queens. Okay. And I have 4 of each of those in a deck. Okay. My number cards are ace through 10. And there are 10 of each suit. So there's a total of 40 total number cards in a deck. Okay. So each suit has 10 cards. We consider the ace a 1. Okay, so we're going to look at a couple different problems involving all of these types of things. I will leave quite a few for you to go ahead and practice with. All right, so let's go ahead first, and I'm going to look at a die, and I'm going to look at example 1, and that's on page 124. And I roll one 6-sided dice once. My probability of rolling a 2 is, well, we talked about each time you roll it only once, each one was 1/6. So possibility, if I roll a 6-sided die once and getting a 2 is 1/6. If I look at part B, a number less than 4. Okay, so the numbers less than 4 are 1, 2, and 3. Each of those has a probability of 1/6. When I add those together, I get 3/6, which simplifies to 1/2. Okay. Part C, number greater than 7. I'm going to go ahead and use some abbreviations here. When you go ahead and roll a 6-sided die, can you get a number greater than 7? Absolutely not. Doesn't exist. So my probability is 0. There's no way if I roll one 6-sided die, I'm going to get a number greater than 7. A number less than 6. Okay. All numbers on the die, 6-sided die, are less than 6, so my probability, because remember we totaled them up earlier, is going to be 1. Okay. Now let's go ahead and look at an example that involves cards. Okay. Okay. And this is on the bottom of page 125. Okay. Example 3. And I am dealt one card from a standard 52-card deck. I want the probability of being dealt an ace. Okay, so I'm using the whole deck. And how many aces are there? Well, there's one ace for each suit. So I have a total of 4 aces. All right. And if I go ahead and put that as the total number of aces I could get over the number of cards in the deck, I get 1/13. Okay. If I look at part B, I'm looking at a red card. Okay. Now, my red cards are the hearts and the diamonds. Okay. And each of those suits has 13 cards. So my total possibility of getting them is adding 13 and 13, or getting 26 over 52. And 26 over 52 simplifies into 1/2. And that makes sense because half the suits are red suits, half the suits are black suits. So that totally makes sense. If I look at part C, a red king. Okay, 2 suits are red, and there's one king in each of those suits, so I have a total of 2 suits, one from diamonds and one from hearts, over my total number of cards, and that's going to equal 1/26. Okay. The last example I'm going to look at for you before I go ahead and move on is going to be example 5 on 126. Okay, and we're looking at a genetics chart. I'm not going to go ahead and read the whole thing. I'm going to go ahead and draw the chart for you. Okay, and we're looking at the chances of a child getting a certain disease. So we have the second parent who is a carrier of, I believe, a cystic fibrosis gene, and a first parent, okay, that also is a carrier. Okay. And so there's a chance here that the first parent and the second parent don't transfer over that cystic fibrosis gene. There's a chance here that the child could be a carrier from one parent. There's also a chance here that that child could be a carrier. And then there's also a chance that that child will go ahead and get both genes, one from each parent, and totally go ahead and have cystic fibrosis. Now they ask us for a chance that the child will be a carrier. Okay, so the carrier, we know that they're a carrier here. They have one small c, that means the carrier. There's one small c here, which says they're going to be a carrier. And if they have cystic fibrosis, they're definitely a carrier. So I have 3 out of 4, okay, that I can have it. But remember, we're just talking carrier here, okay? This means the child actually has cystic fibrosis. We're just looking for the carriers. The actual just carriers are right here. So we actually have 2 over 4. This child has the disease, okay? Therefore, it's not a carrier, they actually have it. So the chances of being a carrier in this case is 1/2. If they were going to go ahead and actually have the disease, then that would be 1 over 4. And not a carrier, okay, not a carrier is this last one right here, is also 1 over 4. Okay, so if they're just a carrier, there's only 2 options for that. All right, well, go ahead and try the rest of them, and if you need anything, go ahead and hit me up, and I will meet you on the other side.